Hello and welcome everyone. My name is Mark Henry, and today we're going to be talking about how to use Netflow and IPFIX to identify security issues. A little bit of housekeeping background stuff for everyone. All of the attendees are on mute during the presentation. We will be taking you off mute at the very end, so if you have questions in between now and then, feel free to use the GoToWebinar's chat window. Myself and Paul will be keeping an eye on those, so we'll be sure to answer those during the presentation itself. When we're done the presentation, which will include both some PowerPoint and some live work with opFlow. Oh, sorry everyone, as Paul just pointed out, I'm not sharing my screen out. So there we go. Thank you, Paul. So as I was saying, at the end of the presentation, which will include the PowerPoint that I'm now actually sharing out with everyone, and a live demonstration of some of the features of opFlow and opFlowSP, which are opMantic's Netflow and IPFIX solutions. When we're done the canned presentation, what we'll do is we'll stop recording at that point. We'll unmute the microphones for all of the attendees, and then open the floor for questions. Again, if you have questions during the presentation, feel free to use the GoToWebinar questions or chat panel. Type them in, and we'll answer them during the presentation. So just a recap briefly of the topics we're going to cover today. We'll be talking about how to configure opMantic's opFlow and opFlowSP or opFlow service provider products to analyze Netflow and IPFIX in your network. We'll be touching on how to use Netflow for anomaly detection and incident response. Those are actually very, very wide topics, and depending on the types of devices you have, the types of flows you're capturing, and also how you're using opFlow and opFlowSP will determine how well you can respond to anomaly detection and incident response. And then finally, we're going to touch on troubleshooting with opFlow and opFlowSP as well. So some useful references for everyone. If you haven't noticed or you haven't seen the little text window at the bottom of your GoToWebinar panel, we have uploaded a copy of today's PowerPoint to the handouts panel. So you should be able to download a copy of today's PowerPoint. We'll also make that PowerPoint available as a PDF that you can download from our website later on today or early tomorrow morning. So we always put up each of our videos and host them on opmantic.com in the blog section there. So you'll be able to find this resource, this video, there as well, along with the PDF of the presentation itself. That way you'll have all of these links available to you. But a few good references for you. The first is the opMantic wiki itself. So each of opMantic's products have their own core wiki page, which is comprised of a resources section, an installation administration, and then an operational section as well. There's also the community questions board. So again, community.opmantic.com/questions. You can go and post any questions you have regarding any of opMantic's products. If you have an ongoing active support and maintenance contract with opMantic on your products, you can, of course, email us at support@opmantic.com. And if you have questions regarding purchasing, pricing, if you want help with a proof of concept, if you have questions about features or functionality, you can always email our sales team, which includes myself and Tom Weary here in North America. And you can reach us at usa@opmantic.com. All right, so let's start with configuring opFlow and opFlowSP. The first big piece, and let me just kind of lay this out, opFlow has two different versions that are available for you. You have what we call the standalone enterprise version, just opFlow. So basically any kind of a small, medium enterprise size business. If, however, you're running more as a service provider, you have really large amounts of flow, large numbers of flow, then you really should look at the opFlowSP or service provider version of opFlow. The biggest differences are in opFlow Enterprise, which is what I'll be using for today's demonstrations. The difference is when you go to the main dashboard, you have all of your information is provided from all of your agents at one time live on the dashboard. Whereas with opFlowSP, you're given a blank dashboard with a list of filters, and you have to select an agent, an interface, and a direction of flow before you get the basic dashboard information. And that's simply to allow the dashboard to be able to render faster. There are, of course, some other background information that SPFlow does a little better. It does a little more downsampling of information. And so we'll touch on that, and that's also covered at a very high level on the Opmantic wiki for opFlow. All right, so what is needed to install and run opFlow or opFlowSP? The first bit, it requires a Linux 64-bit OS. Opmantic recommends either CentOS or Debian. We run all of our stuff here at Opmantic on CentOS currently, although we are transitioning a lot of our products over to Debian. We do support pretty much any version of Linux, version 6 or Red Hat RHEL version 6 or higher. We do get well into version 7 as well. So if you have questions about what operating system you want to or can install on, again, shoot us an email to support@opmantic.com or check out the questions board. We'll be happy to help you out. We've done a lot of testing on many different versions and small installs, etc. So happy to help you out, answer any questions you have. So we start out here, we talk about the concept between a small installation or a large installation. And what I mean by that really is the total number of interfaces and flows that you're processing. So it's not just how many interfaces are sending data to opFlow, it's also how many interfaces worth of data. So if you have, for example, a switch with 48 ports on it, and you say, hey, I've got the primary in and out port here, and I want to send all of my flows from that port. What's going to happen is as information traverses all the other 48 connectors on that switch, you're actually not going to use one interface. You're going to use 48 interfaces worth of licensing, and so that's still considered a small installation of 48. We consider a larger installation something north of, let's say, 500 interfaces or 500 agents worth of data. We do have clients who are running in the 6,000 to 12,000 interfaces range and doing very well with opFlowSP. When you do an install of either opFlow or opFlowSP, the install defaults to high volume settings. So all of Opmantic's products have a wide range of configurations that are possible inside opcommon.nmys. And so you can actually change things like which screens are shown on the dashboard, which products are shown, different types of top end, how information is stored, how long it's stored, those types of settings. And the install defaults to a high volume. So it already starts with the concept that it assumes you're going to have a lot of data moving through your opFlow server. You can make changes in your configuration to reconfigure the system from high volume to high precision. But if you do that, you want a very low number of agents. I'd recommend something less than 200. And really, it comes down to not necessarily the number of agents or the number of interfaces, but again, how many total flows are moving through your server. Big question that we get here is, what's the minimum recommended hardware? So one of the directions that Opmantic took in developing opFlow 3, which is a total rewrite over earlier versions of our product line, was to make the decision that opFlow would be able to run on VMs, so virtual machines, not necessarily have to require large dedicated pieces of hardware. Some of the products that are out there on the marketplace that opFlow competes with require 20, 24 CPU, 64 gigs of RAM, a terabyte or more of high-speed storage. And so instead what we said was, rather than going for one device, one piece of hardware that does everything, what we would do is architect opFlow so that it would be affordable to spin up multiple opFlow servers, each server handling a smaller number of devices, interfaces, agents, and that way be able to run as virtual machines and be much more cost sensitive than the idea of having a really large dedicated $20,000 or $30,000 piece of hardware. As a minimum configuration, we recommend 160 gigabytes of hard drive. We do strongly recommend using SSDs for that. Anywhere from 8 to 16 gigabytes of RAM. The more RAM you provide opFlow, the faster it can do its math calculations. And then finally, a minimum of 4 virtual CPU. We've seen implementations that can benefit anywhere from 6 to 8 CPU. More than 8, heading up into 12, tends to not be as responsive, especially as a virtual machine. Another question we get a lot here in the support area is how many days of data are actually being stored by opFlow. opFlow doesn't store information based on how many days of data you want to have available to you. Instead, it stores it based on how much storage you have available. So when you install opFlow or opFlowSP, one of the steps in the installation program is for the system to ask you if you want to cap your database. So what database capping does is it sets a maximum physical size of the database, which is MongoDB, and says, I will only use X amount of percentage of hard drive space for this database. Once it hits the end of that, it acts more like a round robin database and simply goes back to the beginning and starts recording over earlier information. As a result, because you're storing it based on the amount of storage you have rather than the amount of time, you can actually manage your disk and your storage usage. But the downside of that is as you send more flows, more data to opFlow to actually to process and then display, as you send more data to it, it means you'll have less and less time of data available to you because you're storing more data across more flows, across more interfaces or more agents. Then obviously you have less time overall because you still have a capped amount of data that you can use. A strong recommendation we have here is that when you do set database capping, that you do not cap the database to more than 50% of the available disk space. Less is actually better. The reason for that is pretty straightforward. If you have to, for some reason, back up your database to move it to another machine, you have to have as much, the backup of the database takes as much size as the database it does, that it's backing up does. So if your database is 55% of the drive, your backup will take 55% of that drive. And so you'll exceed the available drive space. So we recommend that you cap something less than 50%. And you should also keep in mind that with MongoDB, Mongo does not include the indexes to the database in database capping. So if you cap to 50%, your database may actually use 55 or 60% of the available hard drive because everything over 50 might actually be the indexes to point to all the content that's within the database itself. We strongly recommend also that the database not be located on the same disk as the operating system and the application itself. It really needs to be on a mount or on a drive that is very, very fast. Again, we recommend an SSD. It needs to be very, very fast, and it needs to have nothing else really going on that drive. If for some reason you discover that your database is too big, you're storing too much information, you're taking up too much drive space, if you need to shrink it or if you want to grow it, either direction, you can actually recap the database using a command line. So we have a command line utility called opFlow-cl.pl. It's inside the omk/bin directory. Don't worry, all of that is all annotated on the opFlow wiki. It goes into great detail on all the different options for opFlow-CLI, what it can do for you, and what you can expect from changing the capping size. Keep in mind, if you're shrinking the database, once you shrink it, it will remove information from the database. You can't get that back. So we recommend, again, backing up the database first. And whether you shrink it or grow the database, it can take some time for it to resize the database as it reserves space on the hard drive, creates and rebuilds new indexes, and in the case of shrinking a database, removes information that you don't need. So now that you've got opFlow or opFlowSP installed, configured, running, you've configured a couple of your devices to send Netflow or IPFIX information into opFlow. opFlow's processing them. Let's talk about what you can do with that information now that you've got it. So one of the questions we often get is, something happened on my network, something happened, we're not sure, how can I use opFlow or how can I use my Netflow data to see what's happening? So an anomaly, really, let's start with the concept of what we consider an anomaly. It's any condition that deviates or is different from what a typical traffic pattern is. So that assumes that you as an engineer, you as an operational engineer, understand and are privy to what's normal on your network. What are typical traffic patterns? What kinds of ports, protocols, what servers inside your network should be talking to outside devices, what those outside devices are, where they're located, what's normal, what does that look like? Anomalous activities can include things like denial of service attacks. They can include viruses, worms, people pushing information out. They can simply be peer-to-peer file sharing. So in all of these cases, it really assumes that you understand what normal traffic is, again, for your organization. So let's take a look here. One of the key pieces for anomaly detection will be the conversation summary screen. And you'll notice at the top of the page here, we have a wiki page that goes into anomaly detection and talks a little bit further about it. So let's take a look at this. So this is the main dashboard for opFlow. opFlow would be slightly different. You'd see the filters on the left-hand side, but there would be no charts and graphs on the right until you selected an agent and then an interface. Agents are created automatically, so as you configure devices to send flows to opFlow, as those interfaces and those flows are being processed, every port that's being scanned, every interface is going to generate an interface, or rather is going to create an agent in opFlow, and you can actually drill into these. So for example, I can select B&E Lab RR1. I can come down and select an interface if I want to, or I can just leave that alone. So let's just pick one of these interfaces, Fast Ethernet 00. And I'm not going to pick a specific direction. I'm just going to hit Apply Selection. And so now opFlow is going to recalculate, and we have no data coming from that interface. So let's pick another one. You'll notice I have OP charts configured with opFlow, and you'll see the green or blue button rather up in the top left-hand corner to go and take a look at that interface. All right. So I'm just picking our primary Gold Coast router. And I didn't pick a specific interface from that. I just hit Apply Selection. You'll notice here on the left, all of my interfaces for my agents also have names. That's because this version of opFlow is also connected to my local instance of NMIS, Network Monitoring Information System. So now these are all of the flows moving in and out of just the Gold Coast router. And if I leave that filter in place as I navigate through the system, it'll actually keep that filter in memory and apply that. So let's take a look at the conversation summary. Again, I'm going to leave that agent in place. All right. So from the conversation summary, I'm actually seeing all of the conversations, again, running through that one filter. In the top left corner, I can actually click to show the side menu, and you can see that that filter is still remembered. So I'm seeing that agent selector here. The pieces that I would be concerned with, all right, we had a comment from one of our users. He said, I have noticed on my installation as well that it is very slow to open a new window. Happy to help you out, Dr. Goldschmidt. You have a support contract, I believe, with the company. If you want to send us an email, we'll be happy to get on a screen share with you and help you out with that. Our system here runs a little bit on the slow side. My office is actually in Charlotte, North Carolina, so I'm on the East Coast of the US. And my demo server, which is running on a Mac Mini, is actually in Brisbane, Australia. So every time I click on something, you have the speed of light constraint. The request goes back to that Mac Mini in Brisbane, Australia. It does the calculations to create the page and then feeds the page back to me. And then, of course, I'm feeding that out to you via GoToWebinar. So there's a bit of back and forth conversation that has to happen. And again, you're limited by speed of light. So taking a look at these top conversation summaries. So this isn't a top end display. This is literally every conversation that's happening. We can break this down. We can search by the type of application, the type of protocol, the port, the location. Any column here can be sorted as well. But you'll notice the amount of data that's moving back and forth between Amazon AWS services and SIF, which is one of our internal servers. So for us, I know that that's normal conversation for us as far as the amount, the percentage, the number of packets, the number of bytes, the amount of data that's moving and where it's coming to and from. And I can look through this list and I know where everything's coming from and where it's going to. So here we have media router at yahoo.com. So that's sending information down to demo.opmantic.com. That's the demo server that we're working on. We have some internal communications as well. Akamai Technologies, which is a web host for us. So I can look through all of these. I can sort through any of these if I want to as well. So for example, if I want to sort just down to SRC port and say 443. And see what traffic is happening there as well. So the key here is understanding what is normal for your organization, understanding where these IP addresses are. So for example, 17.132.73.76 is our San Francisco office. So that's the Bay Area. 191 is our area in Brisbane, Australia. So understanding where these IP addresses are, who they're connecting to, where they're connecting from, and what's normal and what's not normal is really what drives your anomaly detection. Also understanding how many packets might be coming in, where they might be going to, what's normal. So for example, with a denial of service attack, you tend to have very, very few packets being transmitted, but the packet sizes tend to be really, really huge. You also tend to have lots of locations that are unknown to you. again, sending very few packets, but each packet size is very, very large. All right, I'm going to send that back, and we're going to go back to the PowerPoint now. So let's talk a little bit about incident response. Again, we have a web page which has a bit more information on incident response itself. We'll touch on a lot of the concepts that are discussed there. We go a little more in depth. We also have a page devoted directly and only to denial of service attacks. So you do want to check out the opFlow wiki section of our website. Read through the different pages that are out there. We have a lot of examples that are on there. We walk you through how to use opFlow in detail for each of these different types of anomaly detection, incident response, how to kind of ferret out denial of service attacks. So incident response. I spent several years working for a healthcare billing organization, and being able to have a system in place where we could identify a breach and be able to contain it and work around it, and also understand what types of data and perhaps how much data had been compromised was critical to our internal processes and our SAS 70 SOC 2 certification. So when it comes to incident response, it's understanding, again, the types of conversations and who or what organization I've got someone who's reported that they've lost audio. Can anyone hear me at this point? Okay. All right, good. Thank you for letting me know that you got audio back. I apologize for that. Hopefully the audio has been picked up on the recording, and you can pick up anything that you've missed from the recording piece. So again, looking at and considering incident response. So starting with opFlow's top end screen, and then from here, looking at the top application conversations. So over on the left-hand side, we have several different topics. So you've got top applications, application sources, application conversations, top listeners, top protocols, talkers, and top TOS. So we're going to look at top application conversations. And again, you have the agent selector at the bottom of the screen. So I can break this down by a specific agent, then from that agent into the agent's interfaces, the agent's directions. And again, this is only the top N. In this case, this is the top 15. That's all set through your opcommon.nmis file. So you control how many items are actually shown here. You can adjust this over in the bottom right-hand side on the fly. So if you want to show more, right? So these are the top application conversations. So again, you've got the source, the destination. So you've got the source and the destination, right? The application that's running, and you can, we come pre-fit with a lot of applications pre-assigned in here. But if you know for a fact what these ones are internally, if they're a specific internal application, running a specific port, using a specific protocol from one machine to another, you can actually reassign this to have a plain language name in there as well. We also have the idea of ports, bits, packets, flows, bits per second, average packets, percent bytes, percent packets, percent flows, and that's percent of the total, right? Looking at all the different pieces that are here, right? There are definitely some pieces that I perhaps want to look into. Some of those would be the concept that this top application conversation, this one's running 65% of the total volume, but this one is running 41% of the total number of flows. Now, this is actually common. So this is Google's public DNS. It's running on the domain. It's running on port 53. Totally expected. Okay, I understand why the total number of flows are there. I'm calling this out to you so that you can, again, as you spin this up and you start sending flows to opFlow, start walking through these and reading through them and familiarizing yourself with sources, destinations, applications, ports, how much data should or should not be traveling through those at different times of the day. But those are the key pieces that you'd look through, is understanding which of these locations, anything that's sourced from inside, where are you sending it to? Anything from outside that's coming in, what is it that is, what's that connection? Why is that connection there? All right, head back to the dashboard again. Let's go back here to incident response. So troubleshooting opFlow. So we've provided a link here to the opFlow main troubleshooting page. There's a lot of walkthroughs that are on there on how to look at different ways for opFlow. The simplest and the fastest key piece that I use is this operational status report. So let's just take a look at that. Back over to opFlow, views, operational status report. Now, the operational status report is going to tell you how well the opFlow system is actually processing incoming information. So the first step, of course, is you've configured your device, your router, to send flow information into the opFlow server. That information is received by opFlow and handled by NFDump or NFCapD. So NFCap is going to break apart the Netflow and the IPFIX information. It's going to break it apart, reorganize the information, and then pass it along to opFlowD, which is actually going to do a bunch of processing against it and insert it into the database, into the MongoD database for you. So you'll see with each of these rows, you'll see a load cycle. It'll tell you what its current status is, whether it's in progress or completed. It's going to tell you whether it's okay or if there's a problem with it. It'll give you information about that. It'll give you the NFCapD file, that was processed. It'll tell you how long it took to load that NFCapD file, how long it took to insert it into the MongoD database, how long it took to apply any filters that you might have created, how much time it took to process those endpoints, how many flows were inserted or included in that, how many total conversations, and how many unique IP addresses were included. A key piece for this is that insertion time, because that's how long it took to take the information and put it back into the MongoD database. If that insertion takes too long, Mongo will actually time out and you can lose that entire process cycle. It'll just get dropped. So that's one of the key pieces you want to look at. So if information is not showing up in your database, if you go to an interface and it tries to load and it says there's no data, look for these load cycles. See that they're actually completing properly. You also want to see that these summary cycles, whether they're hourly, daily, weekly summary cycles, are running and that they're completing. And again, how long did it take to do the summarization? How long to do the aggregation? And then how long did it take to do the insert for that piece? And you can scroll back. I think this defaults to just the last 2 hours. That's handled in the drop down at the top of the screen. But you can actually look back if you want to, let's say, look back 24 hours. I can let this go, and then what we'll do is I'll sort on the status column. See if we can find anything that did not complete. So status is okay, and I can sort on the type column, and they're all completed as well for the last 24-hour time period. So I can see that my opFlow server is processing everything that's coming into it. opFlow is licensed based on the total number of interfaces of data interfaces that flows are moving through, and that's kind of a key point to understand. It's not the number of agents, it's not the number of interfaces that are sending flow to the server. It's the total number of interfaces the data is moving through. So again, that example where you might have a 48 port switch and you're using the main connection port to send flow data from, but data is moving in and out of all 48 ports, and a lot of that data isn't moving from one port to another. It's moving in and out of that switch. It's heading northbound in your architecture. And so at some point, you may end up using all 48 ports on that of licensing. And so if your system is becoming sluggish, if it's not storing information, you can look down at the bottom. If you've exceeded your licensing, that green bar at the bottom should turn red. If your license has expired, it'll be red as well. More importantly, you can also go to the help dropdown and hit help about, and you'll get some good information here. It'll say currently 99 of 99,999 interfaces are active. So there are 99 interfaces used in our system currently. It's important to understand that if an interface has had traffic at one point and that data is still in the database, that interface is still using up a license key. Even if that interface is no longer active, if operational status is off, if you've unplugged the cable from it completely, if data is still in the database, it's still using up a license. Another piece you should look at is help database info. Let's take a look at that. So from here, we're going to get a lot of good information about our MongoDB. So it's going to give us our Mongo version, our host, its uptime, current status, how large it is, how much data is moving in and out of it, total amount of storage, total size, total number of flows that are being processed, and then each of the different databases. So for example, each of these pieces up here is a separate database. So the flows database is the one used by opFlow. The NMIS database is by NMIS. The OP address database for OP address, and on. When it comes to opFlow, really the one database you care about is your DB's database. So you can see its database size is 3.2 gigs on mine. Uncompressed, that would be 10.21. We do strongly recommend you use Wired Tiger, so the Wired Tiger storage engine. If you're using the Opmantic installer and it's installing MongoDB for the first time, it will configure MongoDB for Wired Tiger. If you have an older install of MongoDB, pardon me, you'll want to check and see what your storage engine is for MongoDB. Again, we do strongly recommend Wired Tiger. We've seen compression schemes as high as 33, 34% with Wired Tiger and with our data. So take a look at that, and you can see that here, going from 10 gigabytes down to 3.2. That's actually about 70% compression here. Okay, question was, what is the menu and item for DB info? Okay, let me go back to here. That is help database info. And just a trick for people, if you're using all of our products show up in a browser window. I couldn't think of a browser. In the browser window. So you can, of course, I'm going to right click on this menu option, and I get this this little contractual right click menu. I can hit open link in new tab, which can be really helpful, right? So, and there's database info coming up here. We had a comment from someone that says, I don't have that option on my install. So we are running opFlow version 3.0.11. I believe that the database piece was new. This database info piece was new in the .11 release, which came out, I think, about 4 months ago. So you should take a look at that. If you don't have access to that piece, again, shoot us a ticket into support, and we'll be happy to help you out. That may just be a setting inside your user account. All right. So that covers everything for today for using Netflow and IPFIX to identify security issues with Opmantic's opFlow and opFlowSP products. I appreciate your time today greatly. I'm going to turn off the recording now and then open the floor for questions.